Okay, here the recording in progress. So, start sharing the screen. All right, so I'm just about to give you a quiz. I was on 4.8, and I may very well come pretty close to finishing 4.8 today. So we're pretty much okay time-wise, ahead of schedule. So I'll give you the quiz. I'll lecture a little while. I won't take up the entire class period, but we'll probably finish somewhat early. So again, I can give you some more time to work on the quiz. Okay, our next exam is next Friday. That will be November the 5th. It's on Trig. So you know the rules by now. You would be responsible for all of this stuff, and you turn in all this stuff for the homework. Okay? We have 2 exams after that, but they're very short in material wise. Okay, so we have exam 5 coming up on Friday, November 19th. Last exam, I'm not sure I'm going to have it on the Thursday. We'll see. I might move it back to Friday, but I might keep it. We'll see. Okay, our final exams on the first day of finals, Monday, the 13th from 8:10 to 10:40. Please notice the starting time for the final exam is 8:10, not 9:10. Okay, we'll talk more about it when it gets a little bit closer. All right, quiz time. So let me show you the quiz. Have your cell phone out and ready to take pictures or get ready for a screenshot. Worst comes to worst is on the video. All right, and here we go. Okay, you're given that the tangent of t is 3, and t is in quadrant 3. So based on that information, give the values of the other 5 trig functions of t. Okay, I'll give you an advice. There's an identity for tangent. Okay, one of the Pythagorean identities. Based on the tangent, you can get the secant, right? There's an identity, 1 plus tangent squared t equals secant squared t. And once you have secant, you can get its reciprocal cosine. And once you have the cosine, the ball gets rolling. So I think you should be okay from there. Make sure you notice that you're in quadrant 3. So quadrant 3, you already know the tangent is positive, but what about the sine and the cosine? Okay. All right, so tangent of t is 3. You're in quadrant 3. Give the values of the other 5 trig functions. Of course, show all your work. Number 2, 1 period of 2 secant x minus pi over 4. Label key points. Okay, so some things, you know your basic secant function, then ask yourself, what does the 2 do? And what does the x minus pi over 4 do? Okay. Number 3, verify the identity. Show that cotangent x plus tangent x equals secant x cosecant x. And that should be pretty straightforward. Work it out. Draw yourself a little line down the middle like we did in class. Work on this side, and hopefully you get them to match. When you get them to match, then you can cross over and say that they're equal. Okay. So that's pretty much it. Due at 11:59 p.m. tonight. You have more than half a day. Well, unless you're watching a video and you're getting the video later, then you have a little bit less than half a day. But, you know, you still have more than enough time. It's open everything. But again, do it the way that we did it in class is the main thing that I want to mention. Okay, so do it 11:59 p.m. I will make this disappear. If you didn't get it now, you can always watch the video when it comes out in about an hour or 2. All right, so I'll continue on with where we were on the inverse trig functions and how to do some of the problems at the end. Okay, so some of that kind of stuff and verify the given identity. So I'll show you some of those. Okay, arctan of tangent 7 pi over 6, 27. It's a little bit tricky. You might think, oh, 7 pi over 6. Well, let's try it. What is the tangent of 7 pi over 6? I'm over here. Okay. The reference angle is 30 degrees of pi over 6. If this is x comma y, this is negative x comma negative y. So tangent of 7 pi over 6 is the same as the tangent of pi over 6. By the way, one way you can also tell that is, the period of the tangent function is pi. These are pi apart from each other. Therefore, they have the same value. Okay. And arctan returns a value between negative pi over 2 and pi over 2. So I cannot have the answer as 7 pi over 6. Okay. Pi over 6, however, is between negative pi over 2 and pi over 2. So even though I'm not ever figuring out what the exact value of tangent pi over 6 is, we could. I know the answer is just going to be pi over 6, not 7 pi over 6. Okay. So that's a little bit tricky. Okay, so the argument again is, if this is x comma y, this is negative x comma negative y, but the ratio sine over cosine or y over x is going to be the same. Okay, and since arctangent returns a value between negative pi over 2 and pi over 2, my answer is pi over 6, not 7 pi over 6. Okay, now for some of the problems at the end, starting with 29, what happens when they mix up cosine and arcsine and stuff like that? Okay, then we have to go back to our right triangle trig. So recall for right triangle trigonometry, if you have a given angle, let's call it theta. This is the adjacent side, opposite side, hypotenuse. We can do our SOHCAHTOA. Sine of theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. And tangent theta is opposite over the adjacent. Okay. All right, so with that in mind, how do I do cosine of arcsine 4/5? Now, the way I'm showing you isn't the only way to do it, but I want to show you by means of a triangle. All right, so what I do is I call this theta. Theta is equal to arcsine of 4/5. Well, that says sine of theta is 4/5. Ultimately, I'm trying to find cosine theta. I could do this by terms and identities, but let me do this in terms of a right triangle. So I draw myself a right triangle. Okay, I know the sine of theta is 4/5. So I go opposite over hypotenuse. So the opposite is 4, hypotenuse is 5. Okay. You may have heard in trig the 3, 4, 5 triangle, right? 3, 4, 5 is a right triangle. 3 squared plus 4 squared equals 5 squared. Okay. Now, if you didn't know that and you just want to use Pythagorean theorem, that's fine. You can go x squared plus 4 squared equals 5 squared. You'll get 3. 4 squared is what? 16. 5 squared is 25. 25 minus 16 is 9. Square root of 9 is 3. So it's a 3, 4, 5 triangle. It's a shortcut. Your trig teacher may have taught you that 3, 4, 5 is a right triangle. Now I just want cosine of theta. So cosine is adjacent over hypotenuse. So that would be 3 over 5. So the final answer is 3/5. Cosine of theta is 3/5. Okay, that's the way it goes. 33. Cosine of arctan of 4. Number 33 there. Cosine of arctan 4. So I'll call this theta. In other words, find cosine of theta. So theta is arctan 4, which means tangent of theta is 4. Rewrite it without the arc. So you know you're not taking the tangent of 4. So I'm taking tangent theta is 4 over 1. I draw my triangle. Tangent TOA. Tangent is opposite over adjacent. So 4 over 1. Do your Pythagorean theorem. A squared plus b squared equals c squared. 1 squared is 1. 4 squared is 16. Add them up, you get 17. So the hypotenuse is radical 17. And I want cosine. So cosine of theta is adjacent over hypotenuse. So adjacent is 1. Hypotenuse is radical 17. So final answer, cosine of theta is 1 over radical 17. Okay. All right, so that's that. Okay, some of these get a little bit harder. 35, cosine of arc sine 3/5 plus arc cosine of 4/5. Oh boy. Call this A, call this B. So ultimately, I'm trying to find cosine of A plus B. I have a formula for that. Put that on your cheat sheet. Cosine A, cosine B minus sine A, sine B. All right. A is arc sine of 3/5, therefore sine of A is 3/5. B is arc cosine of 4/5. That means cosine of B is 4/5. Okay. So I draw my triangle here. So sine of A is 3/5. That makes this 4, 3, 4, 5. Cosine of B is 4/5. So cosine of B adjacent 4/5. That makes this 3, which basically tells you A and B are the same. You know, that's not always going to happen, but it's true in this particular case. So I have everything I need. Sine of A is 3/5. Cosine of A is 4/5. Cosine of B is 4/5. Sine of B is 3/5. Okay. And I'm ready. Cosine A plus B. Cosine A plus B is cos A cos B minus sine A sine B. So that's 4/5 times 4/5 minus 3/5, 3/5. 16/25 minus 9/25, 7/25. Okay. Okay, 37. Show that arc sine of negative x is the opposite of this arc sine of x. Okay, so I decided to call this theta. Let theta be arc sine negative x. That means sine of theta is negative x, or negative sine theta is x. Okay. Since sine of theta is already known to be an odd function. So since it's odd, negative sine theta is the same as sine of negative theta, which is x. Okay, now I look at negative arc sine x, I call that, say, capital A. That means arc sine of x is negative A. We write this as sine of negative A is x. Since sine of negative A is x, and sine of negative theta is x. Okay. Take a look at what we have here. That means negative A is the same as negative theta, or A equals theta. Okay. So that basically means arc sine of negative x is the same as negative the arc sine of x. Okay. So theta is arc sine of negative x. Okay. And this is A, they have to be equal to each other now. So that shows arc sine of negative x is the same as negative arc sine of x. Okay, let's see, problem number 39. I'm not going to go much longer, so we'll probably be done in 5 minutes, 10 minutes at the most. At which point I'll let you ask questions, but if not, I'll let you go and get started with the quiz. Show that arc cosine x is arc sine of radical 1 minus x squared. All right, so arc sine of radical 1 minus x squared, call that theta. That means sine of theta is radical 1 minus x squared over 1. Okay, so I drew myself a triangle. Sine of theta is opposite over hypotenuse, so radical 1 minus x squared, 1. Believe it or not, that makes this side x. You can use the Pythagorean theorem for that. If you know this is 1, if you square it, it's 1. The square of this is 1 minus x squared. So what's the difference between this and this? It's 1 minus, parentheses, 1 minus x squared. That's x squared. Well, that forces this to be x. So what is cosine of theta? Well, x over 1, which is x. Okay, now let's try arc cosine of x, and we call that a. That means cosine of a is x over 1. Same picture. Okay, so that basically means a is the same as theta. A is the same as theta means arc cosine x is arc sine of radical 1 minus x squared. Okay. So that's that one. Okay, 43 and 45. 43, solve for angles between negative pi over 2 and pi over 2. Okay, tangent squared x minus tan x minus 2 equals 0. And the angle is between negative pi over 2 and pi over 2. Okay, you factor tan x minus 2, tan x plus 1 equals 0. That means tan x minus 2 equals 0, or tan x plus 1 equals 0. Right? This gives me tan x equals 2, or tan x equals negative 1. Tangent of what angle is negative 1 between negative pi over 2 and pi over 2? The only such angle is negative pi over 4. In this case, you could just say arctangent. So arctangent of negative 1 is negative pi over 4. This is just some extra. This is the point radical 2 over 2, negative radical 2 over 2. You don't really need that. It does show that the ratio is negative 1, though. Okay. The other value of x is inverse tangent of 2, which is not a nice number. Okay, so you just punch that in your calculator. And I got about 1.107 radians. You're in radian mode. Okay, so let me see if I can show that to you. Switch my mode to radians to inverse tangent. Yeah, 1.107 radians. So I did inverse tangent of 2, so I hit 2 to second function inverse tangent, which is way up here for me. 1.107 roughly. So that's that. Okay, finally 45, and then I'm done. So if anybody has any questions, you can bring them up. Otherwise, that's going to be it for today. 45, a lighthouse is 4 miles from a straight shoreline as shown in the figure. Okay, lighthouse for x. If the light from the lighthouse is moving along the shoreline, express the angle theta formed by the beam of light and the shoreline in terms of the distance x. Okay, theta x 4. Theta x 4. Well, that's the opposite side. That's the adjacent side. So tangent of theta is x over 4. You want a function of theta, so I just take inverse tangent. So theta is inverse tangent of x over 4. Okay. All right, and that is it as far as what I was going to cover. I do see some question in the chat. So let me see if I can go over that one. And if anybody else has a question, feel free to bring it up. Okay, C41. Okay, where does 1.107 come from in number 43? That was the inverse tangent of 2. I just punch it in my calculator. And yes, of course, you can certainly use a calculator in the exam. Every exam you're allowed a calculator. So that was the inverse tangent of 2, right? I punch it out. Let's see, where were we? Number 41. tangent of arc sine of X is equal to that one. Tangent of arc sine of X. Call that theta. So in other words, find tangent theta. So theta is arc sine X. Rewrite it without the arc. So I'm taking the sine of something. What do you think I'm taking the sine of? Well, could I be taking the sine of X? No, taking the arc sine of X. Therefore, I must be taking the sine of something else. What else is there? Theta. This X, which I'm going to write as X over 1 in order to do my triangle. Theta. Sine is opposite over hypotenuse. I need to find the adjacent. Temporarily, I'll call it y. X squared plus y squared equals 1 squared. Y squared equals 1 minus x squared. Take the square root. Y is radical 1 minus x squared. Okay, so what am I trying to find? Tangent of theta. So tangent in my SOHCAHTOA, tangent is what over what? It's opposite over adjacent, is it not? So x over radical 1 minus x squared, and that pretty much does it. You don't have to worry about this other stuff here. Where'd it go? Absolute value of x is less than 1. Well, yeah, it cannot be 1 because then you'll be divided by 0. And arc sine only returns stuff between -1 and 1 anyway. Okay. X cannot be 0 because if x is 0, you don't even have a triangle. But when you're working the problem out, you don't really have to worry about that here.
So when like doing a problem like this, as long as we have like the triangle and like the Pythagorean identity work, and then just restate tan of arc sine x equals x over square root 1 minus x squared. That's all the work we really need, right? Like there's no other way to like put an answer like that out. Does that make sense?
Just do it the way that I have it over here. That should be fine.
And really quickly about 37, like so you were saying like so like theta, 37, theta equals arc sine of -x, so sine of theta equals -x, and theta equals negative arc sine of x, so negative sine of theta equals x, and that is true because sine of theta is odd. That is the definition of an odd.
Right, it's an odd function, so it has the property that sine of negative an angle is the opposite of the sine of the angle. So I believe I use that in the proof there. Like this stuff. Yeah. Okay. All right, I believe I've caught up. Let me check the chat. Anything else? I think I've caught up. Any other questions, please? Otherwise, I'll let you go. All right, I don't see or hear anything else. All right, have a good weekend. Work on the quiz, due at 11:59 p.m. tonight. Open everything. All right, bye, everybody. Thank you.